Hello, everybody. I'm Adrin. I currently work at PyConDE, and my day job is to work on scikit-learn. And I will be telling you about the organization around scikit-learn, scikit-learn-contrib, the recent changes that we've had, and after that, I'll go over a few of the things that we're focusing on right now, some of which have already been released, some of which are on master, and some of which are still being boiled on the stove. So let's talk a little bit about the history of scikit-learn. It started in 2007 as a Google Summer of Code project. There was a little bit of pause there, and it became more active after 2010. And since 2010, it's been on GitHub, and that is the activity you see. It's a little bit tricky to interpret that graph, because at the beginning, the pull requests, which are the contributions that are sent to the repo by the contributors, the commits were not squashed, meaning that if I was debugging something and I had like ... as my commit messages, all of those would be on the master log. And one of the most popular commit messages from back then is pep8, because obviously we forget to format our code. And we only care about that when it's public and everybody sees our code. So let's look at the later times, the past 3 years. We can look at it a little bit better. It doesn't seem to change much, but it actually does. The peaks are obviously the releases. There's more activity around any repo, any library whenever there's a release, but also a lot of the commits are not squashed around then, when like the ones that are related to the release itself. But when you look at the idle area around like between releases, there's a big difference. Like 50 and 100, that's a twofold increase. So when you look at it, it started around late, like third quarter 2018. So what happened then? That was when in INRIA Foundation, which was one of the places that a lot of development, scikit-learn development was happening historically, they started to have a scikit-learn consortium in which they were like, okay, we accept money in donations, and we will use that money to fund full-time maintainers. And now they have 3 or 4 full-time maintainers. That was a huge boost. Other than that, we now have in total, other than the consortium, we have the Columbia University in New York, who's funding Andreas Müller. And Andreas Müller has a fund which is supporting Thomas and Nicola. University of Sydney is supporting Joel, without whom we wouldn't have this scikit-learn, really. He's great. And Anaconda's funding me. So this resulted in the whole repo being a lot busier, and a lot of players in the game. We have obviously the contributors who are some of the contributors are the core contributors. Some of them are hopefully you, and it's a lot. You get a lot of noise. Some of it is noise. A lot of it is good contribution, but it's a lot of work. We have the core contributors. It grew. We had through time a lot of core contributors who were like they had access to the repo, but they're not necessarily active. There were fewer active core contributors than it grew recently. And then now we have the sponsors. And then what about the decision-making process? It used to be that unless there is a unanimous consensus on anything, it wouldn't go in. So if it was an API change, if it was a new model being included, unless all core contributors agree on that, it wouldn't go in. As a result, we had long-standing pull requests. Things that were really easy. They were not big, but they touch the API. Anything that touches the API is sensitive. So they would be there for 5 years and there was no decision. We didn't have any BDFL. And we also didn't want to have any BDFL. But in a sense, any core contributor was kind of a BDFL because everybody had like a veto. So we started drafting a governance model. This was, I guess, passed around January this year. We have contributors who are the usual contributors. We have the core maintainers. These are the people who have access to the repo. And then we have a technical committee. The a new core developer is added to the team if somebody nominates them and there is a vote and the vote passes. Any decision that needs to be made, there is a vote. If 2/3 majority of the core maintainers agree on that, it passes. If some decision is more controversial, it doesn't have 2/3 majority. If 50% of the technical committee agrees on that, then it passes. As a result of that, we have managed to pass a few changes, and there has been a lot more changes recently compared to the past, because there is a consensus with this definition now. So what's now the scikit-learn versus scikit-learn-contrib? Scikit-learn is an organization there on GitHub. It has the website, it has the main repo, and a bunch of other stuff that are directly related to scikit-learn package. Whereas scikit-learn-contrib is an organization under which there are a whole bunch of other repositories, a bunch of libraries. They need to satisfy certain constraints. They need to be documented. They have CI. They support Python 3. They're scikit-learn compatible, and there's around 18 of them. And if they don't, so it was something that doesn't really go into scikit-learn, but it's nice, and the scikit-learn community could use it. It could go there. Scorch could be there. The benefit of that is that if it's not a very visible library, it would give it some visibility. Then on top of that, we thought, okay, we get some pull requests or some requests in general on scikit-learn regarding new models. Some of them are really new models. Some of them are old models that aren't included in scikit-learn. What do we do with them? The inclusion criteria is kind of pretty high. If there is a paper backing the model and it has at least 300 citations, then we may think about including them. But not everything gets in. But a lot of really good models are out there that people could use. What do we do with them? We decided to have scikit-learn Extra, which we moved a bunch of those pull requests to sklearn Extra. You can install that, and these are more experimental models. They're newer, they're fancier, they're more closer to the bleeding edge of the science, because sklearn is very traditional machine learning. And it's well documented. We are still working on having, instead of, you still need to install it from source. We are thinking about having a binary distribution, for it on ConDE and, PyPI, but those are still in progress. And things that are included there, some of them are, more popular than others, like sklearn pandas. sklearn doesn't really support pandas. It doesn't have pandas in, pandas out. It kind of does that with a lot of overhead sometimes, but it works. Imbalanced learn if you have imbalanced data. Metric learn, deslib is dynamic on some models. Pretty cool. And a whole bunch of this. So one thing that happened with the decision-making process change was that, okay, now we need, whenever we want to make a decision, we need a proposal to make that decision. Those are the ones that we're calling SLEP, scikit-learn enhancement proposals. The last one that we talked and it finally got accepted was keyword-only args. A keyword-only argument, it means that if I have, look at up there, I have SVM and SVC, and I'm passing the two parameters positional, as in that I'm not saying C equals something and kernel equals something. The first line is positional passing of the arguments. The second one is keyword. Now, Python 3 gives you the option of forcing keyword-only argument, as in the user cannot pass those parameters without mentioning the name of the argument. And it's pretty useful for some of the models that have a lot of arguments. Here, optics, for example, it has those many arguments. The second variation is not really understandable. It's bad code. That's one part of it. The other part is that as maintainers, whenever we wanted to add a parameter to a model, we had to add that at the end of the list, not to break anybody's code. But that makes the whole system more chaotic because the list of the parameters is just random. So now this is now passed, and we're gonna like through some deprecation cycle, we're gonna force everybody to pass the parameters with the name. I'm gonna talk a little bit about some of those slips more, but these are some of the things that I'm gonna cover today as like whatever time allows. Well, we dropped old Pythons. It's Python 3.5 only, and the next release probably will be 3.6 plus only. We will be supporting the last 3 Python releases, and by the time that we release, Python 3.8 will be out. There's a nightly build now, so if you fancy using something from master, you can just install the nightly build, and it has its own documentation website, which is just dev at the end instead of stable. And there has been a lot. There's a specific fund to on improving the parallelization and the performance of the scikit-learn and pickling, and a lot of effort goes there, and nobody really sees them. But they do really need to get the credit for it. Now, the rest of them. One thing we worked a lot on was column transformer. It was, people really like it. It's really useful. You have a bunch of fields. Some of them are numerical, some of them are categorical. You don't want to apply the same kind of transformer on all the fields. You choose your categorical ones, for example, here, and then here, I'm saying, the title, I want to do count vectorizer. The city, I want to do a one-hot encoding. And then that's the output you get. It's pretty neat. And it's the first transformer, the first model in scikit-learn that understands pandas, as in you can pass names of the columns and it understands them. Before that, you would always have to pass the number of the column. It was experimental, not anymore. Needed a lot of bug fixes. It was new kind of for us because we needed to support pandas. It still has some issues, working on them. And it supports output feature names. So you can, because when you do those transformers, it is important to know, okay, which feature is what were they before? So you can get feature names and it gives you that. Unless you, for example, have pass-through. It doesn't work. So this is one of the things that resulted in long discussions about how do we support feature names? As in, like, how do we support pandas? But one of the things that when people mean different things when they say pandas. One of the things is feature names. One of them. What do we do about that? Well, we need to save a lot of information about input and output features. To start with, we need to know the number of input features. If you had a transformer and and a pipeline, and they changed the number of features in the pipeline, there was no way for you to investigate, okay, how many features has each transformer received. So these are API changes. So it's like the input ones and the output ones. But since they are API changes, there's going to be slips for them and a lot of discussions about that, and they're still in the process. And then after that, we can have some feature names. But how do we do feature names? One way was to have pandas in, pandas out. We need something to have the feature names with it, kind of, when we are passing the data through in a pipeline. Didn't want to depend on pandas. Xarray, it was okay, but Xarray depends on pandas, so that was a no. So we are probably going to have our own class, which is completely NumPy compatible. As soon as you do anything on it, it's going to be a NumPy array, but it has feature names in it. And there are already 3 slips in the making, and there's one more coming out. So it will take time, but we are actively working on it. Sample properties. Sample weights are an example of sample properties. Groups are another example. You may have data that has gender, race, or any other attribute attached to it. Those are your sample properties that you don't want to use in your model, but you want to use maybe in your scoring. Or for some other purpose. Or you may have a nested cross-validation, and you have groups, and you want to pass those groups to the cross-validation, the inner one. How do we handle those things? It's pretty hard. The routing is really hard to handle. This is a really long-standing issue, but we are close to solving it. Stay tuned. Resampler, if you want to downsample or upsample in your pipeline, you can't do that now. You can have an estimator yourself and do that, and like those hacks really work. But there is an issue with it. If I fit, I want to downsample or upsample, and I have my resampler in my pipeline. But if I transform or if I call predict, I don't want to downsample. If I give the test data and I want to get the prediction, there shouldn't be any downsampling there. How do we handle that? So we probably will introduce a new verb, fit resample. And there are two competing proposals. One of them is a meta estimator. The other one is just a resampler in a pipeline. And we'll see how that goes. We are going to define now what is public API, what is private API. Up until now, we've had documented API and undocumented API. We're going to have define it and be like, whatever starts with a underscore, it's private. The issue with that is that we have a lot of files that don't have underscore at the beginning of them. So you could import logistic regression through sklearn.linearmodel.logistic, and it sounds like it's the way you should import it. But no, the last logistic is just a file name. And there are things that you can use, but we consider them private, as in we don't want to have them backward compatible. As in we want to be free to change the API. Like one of the issues is that it can be confusing. For example, sklearn.linearmodel.ridge is a module, as in is a file, and then sklearn.linearmodel.ridge regression is a function. So to fix all of these issues, we're defining them and we're practically renaming all the files, adding an underscore with a deprecation cycle. On the models side, the histogram-based gradient boosting models, this is what you have on XGBoost and LightGBM by Microsoft. There was an initial implementation of them in Numba. Then we did that in Python. It's still not mature. It's experimental. You need to explicitly enable that to use it. It's much faster than the original gradient boosting models, to the point that if your data set is large enough, the old ones just don't work. And this one works really fast. But it's not mature. For example, I'm right now working on adding sample weights to the model. But a lot more is coming. We're adding more losses, sample weights, as I mentioned, the categorical features, instead of doing one-hot encoding, for example, a model to be able to handle a categorical feature natively. And it's one of the few models that natively supports missing values. You don't need to impute your data before passing it to the model. Generalized linear models, you can have a loss function that is not the usual one. For example, this is also a long-standing one, but as you see, this is a trimmed down version of another PR, which is adding over 2,800 lines of code. These are not easy to review. And some of the use cases are, for example, if your output values are counts or frequencies, or they are positive valued and skewed, or you have a heavier tail on your output distribution than a Gaussian one. The website, as you can imagine, web development, CSS, JavaScript, none of that is our strong suit. So the website really looks bad. We recently revamped the whole thing. It looks much better, but still working on it. And on top of that, we are working on better documentation, getting started, etc. Plots. The new world of plotting and maintaining them. So you can, let's say you feed your model as usual. Now you want to plot the ROC. Now you can do plot ROC curve and then show that it works. And now let's say you want to fit another model and you want to add the ROC of that model to your plot. You can do that. It accepts the axis, and you can plot it. This was the first one. We started to design the API, the plotting API that we're happy with. Now this is in, and more plotting is in the making. Imputation. Imputing the missing values. If you have missing values and you want to fill them, the simple imputer, you can have different strategies like the most frequent, replace them with the most frequent. There are fancier one coming. I think they're merged, so they are in the nightly builds already. Some of them are not released. For example, the iterative imputer tries to predict each feature using the other features, and it fills the missing values as with the output of the model that it learns. The KNN imputer, it does a KNN on the data, and it fills the missing values using that. And you have the missing indicator, which means that if I impute my data, it means that the data now doesn't have any missing values, but maybe the fact that the data was missing is informative. So another transformer that I can apply on my data is to just have this indicator. Was my data missing in the original data or not? It works like any other transformer. Permutation importance. This is one of my favorites. Versus feature importances of the random forest. So let's say I fetch the Titanic dataset from OpenML. I use a bunch of the categorical features and numerical ones. And up there, I'm adding a random categorical feature and a numerical categorical feature. And then I do the pre-processing for the categorical one is a simple imputer and one hot encoder, and for the numerical ones I do just simple imputer, and then I have a pre-processing that does a column transformer on top of those, and then I have a pipeline. I do my pre-processing and I do random forest classification. I do that, and then the test accuracy is not too bad, but let's look at the model. These are the feature importances of that random forest. As you can see, the random numerical one is the most important feature. On top of that, all the categorical ones are lower than numerical ones. Because inherently, when I do one hot encoding, I'm dividing them, and the importance of one categorical feature is basically the sum of the importances of all the ones that correspond to it, which you don't see necessarily on the feature importances output of the random forest. So instead of that, you could look at the permutation importance, which is I permutate the data on a single feature, and I look at the performance of the model. Does it get worse or not? If it doesn't, it means that the model doesn't care about that feature. The good thing about that is that I can permutate the original categorical features, and then I apply the preprocessing on it. So here I have trained already a random forest. I pass that with some test data to permutation importance. And then I can repeat that process randomly for 10 times, and then I get some confidence intervals for the importance of each feature. As you can see, according to this metric, the random categorical ones and the random numerical ones are down there. But one thing to be careful about is that if you passed your train data, the importances are different, and the numerical one and the categorical ones are actually a little bit more important. That's because the model has actually learned from those random ones. It's overfitting, obviously, but it's learning them. The other thing regarding investigating the models and understanding them is the partial dependence plots. How much an output depends on an input. Theoretically, you could look at it from using any given number of input features, but visually, you can't really visualize it for more than one or two features. Like for 2 features, you can visualize that on a 3D plot, but more than that, it gets hard. Successive halving. This is really interesting. Still not in, working on it. It means that if my hyperparameter space is huge, I cannot do a grid search on all of it. I want to start, and then after the first iteration, I want to cut the ones that have a really low performance. I have no hope there. And then I continue from the ones that have a higher performance. And then I do at each iteration, I cut more of them. And then at the end, I get the ones that are really good. This enables you to explore a much larger parameter space. I had this just in case I was too fast. I wasn't. So I can be done. Thank you.
So any question? Yes. Thank you for the talk and the contributions. Now that I have a little bit more context about how you're thinking about setting up the contrib, scikit-contrib, I was looking through some of the libraries and I saw PyLearn, an implementation of factorization machines. And so I was wondering, what kind of process do you go through? Like what's differentiating between PyLearn getting in versus like FastFM or PyFM, other libraries that leverage the scikit API for factorization machines?
We don't have, so the question kind of implies that we are a gateway and we don't let some of them in, some of them yes. It's more that some of them do apply to be in scikit-learn-contrib, some of them don't. There are some amazing projects out there that, from my perspective, it does make sense for them to be there, but they don't want to. One reason for that, it's like some of it is kind of politics. Because if you're in scikit-learn-contrib, it means that all scikit-learn maintainers have full access to your repo. So in a sense, you're kind of losing ownership. On top of that, there are certain requirements like you need to be documented, you need to be PyPate compatible, like all of that stuff. And some of them don't want to bother with that, maybe. It's not a big gateway. If you satisfy those conditions, it can be in. And if there are multiple implementations of the same model in one space, we're okay to have them.
Any question? Yeah.
I heard that, hello, very good presentation. That there's going to be a sprint about scikit-learn this weekend.
Yes.
So maybe you can tell about that. Yeah.
I'm there. Like as an organizer, I'm there anyway. So I'm going to be at the table. I'm working on scikit-learn, and if people want to contribute, I'm more than happy to help you set up your machine or start your first contribution or continue on your older contributions.
Any other question?
Cool.
I have one, just one very quick one. I was wondering how the imputation functions have been borrowed from imbalanced learn, or what is the difference between them?
Oh, that's a great question. So one role of the whole contrib is to experiment with the API and with the methods. So for example, column transformer is something that was experimented on sklearn pandas. Imputers too. One reason that we started to work on imputers is that sklearn used to be used heavily in academia. Now it is also used in the industry. And in academia, your data sets are much cleaner than in industry. So now, or it's like when you teach, you don't necessarily assume that your data has missing values. But now it's become more and more important. Therefore, imputation is one of those things that there's way more demand on it from the industry side, and therefore it's included. But there isn't necessarily a difference between imbalanced learn imputation and this one. They're cleaner, like it's a higher level of standard. It has to pass those quality checks, but otherwise there's not necessarily a big difference.
Oh yeah, very quick question. Can you approach a little bit? Yeah.
Thanks a lot for the presentation. Quick question on the explainability features. You showed partial dependence plots. What's the roadmap in general on features like that? Because I see a blank space in the Python world on those kinds of features.
So when you look at the major goals in the roadmap, the explainability and interpretability of the models is one of them. Pandas integration is another one. A more stable, some changes into the API is another one. And what I mean by that is that for example, the partial dependence plots, they don't necessarily work with all the models. That's in the making. Some of them are already added. And it's in the process. It's one of those things that now we care about and we focus on. So whenever there's a new contribution, then we work on it. There isn't necessarily a list of things that we have in the queue. It's more that this is a topic that now we care about, and therefore we're gonna like pick on them and like find things that we can implement. Or if there is a contribution, we're gonna focus on that and we prioritize that.
I don't think it's coffee break time. So thank you very much for the talk.
Thank you.